Today we will solve this problem. This is an interesting problem. You must attempt this problem one time before watching the solution. So let's start solving the problem. So we need to evaluate the value of this quantity. So how we will do it? Let's see. So we will start with e to the power x expansion. We can write e to the power x as this is equal to summation k equal to 0 to infinity x to the power k upon k factorial. Right? Okay. Now see that we need to replace k factorial by 3n whole factorial because we need it. Because we need it to get our answer. Right? So how we will do it? See here. Now here k is equal to what? 0, 1, 2, so on, all non-negative integers. Right? Okay. Now if I divide k by 3, then what are the possibilities? K may be completely divisible by 3. That means k may be equal to 3n. Or we can get 1 as the remainder. So k may be equal to 3n plus 1. And our last possibility is k, if we divide k by 3, then we will get 2 as our remainder. So k may be equal to 3n plus 2. These three are the possibilities, right? Okay. So now think clearly. Now if I combine all three possibilities, then what we will get? Think. Yeah, absolutely correct. We can easily get back to this, right? Why? Because if we expand all this by putting the values of n, right, you can easily get back to this thing. Okay, clear? Okay. So now what we will do, we will apply the same logic here. So we can write e to the power x as summation n equal to 0 to infinity, and here we can write this as x to the power 3n upon 3n factorial plus x to the power 3n plus 1 upon 3n plus 1 factorial plus x to the power 3n plus 2 upon 3n plus 2 whole factorial. So these are the possibilities, right? These are the possibilities. And we combined all these possibilities and got this thing is equal to this, and this is the same logic we used here. Clear? Okay. So now what we need to do, we need 1 in the numerator, so we will put first, what we will do, we will put x equal to 1. That will come in your mind at first, right? So let's put, so we will get e equal to summation of n equal to 0 to infinity, and here we will get 1 by 3n whole factorial plus 1 by 3n plus 1 whole factorial plus 1 by 3n plus 2 whole factorial, right? Okay. So now what we will do, we got 1 by 3n whole factorial, that is correct, but we also got 2 extra terms. So what we will do now, what we will do, we will put x equal to omega. What is omega? Omega is the cube root of unity you learned in complex numbers. Okay, so we will get what, e to the power omega equal to summation n equal to 0 to infinite. Now we will use the properties of cube root of unity. Okay, so omega to the power 3n is equal to 1. Omega to the power any multiple of 3, that is equal to 1. You know it. So we will get 1 by 3n whole factorial plus, now see here, omega to the power 3n is equal to 1 into omega. So we will get omega divided by 3n plus 1 whole factorial plus, here omega to the power 3n into omega square, right? Here we will get omega to the power 3n plus 2, so you can write it as omega to the power 3n into omega square. That is a simple logic. So omega to the power 3n is equal to 1, right? Omega to the power 3n is equal to 1, so we will get omega square here divided by 3n plus 2 whole factorial. So when we will put x equal to omega, we will get this result. Clear? Okay. Now what we will do? We will put x equal to omega square. So we will get what? E to the power omega square. This is equal to summation n equal to 0 to infinity. Now here omega square to the power 3n, so that is omega to the power 6n, and 6n is also a multiple of 3, so that is also equal to 1, so 1 by 3n whole factorial, right? Plus, see here, we will get omega square whole to the power 3n plus 1, so that is omega to the power 6n into omega square, so that is also equal to omega square divided by 3n plus 1 factorial, right? Plus, here we will get omega to the power 6n into omega to the power 4. Omega to the power 6n is equal to 1. Now, omega to the power 4 is equal to what? Omega. Omega to the power 4 is equal to omega. So, we will get omega divided by 3n plus 2 whole factorial. You need to know the properties of omega clearly, okay? Okay. That is basic cube root of unity. So now, see what we will do. Now, let us say that we will add all this. Okay, so we will get e plus e to the power omega plus e to the power omega square. So if we add all of those, what we will get? See here. Summation n equal to 0 to infinite. This thing is common for all. So you can take that common. That is summation common, okay? This 1 by 3n whole factorial, there are 3 times, right? So we will write 3 by 3n whole factorial. Okay, no problem. Now see here, if I take 1 by 3n whole factorial common, 1 by 3n whole factorial common, in bracket we will get 1 plus omega square. Now you know that 1 plus omega square is equal to what? 0. 1 plus omega square is equal to 0. So this term will simply be cancelled out. Clear? Same like that for these 3 terms, if we take 1 by 3n plus 2 whole factorial common, so we will get again 1 plus omega square, which is also equal to 0. So that term will also be cancelled out and we will get only this. We will only get this, okay? Okay. So 3 is the constant, so we can move it outside of the summation sign clearly. Okay. So we will get summation n equal to 0 to infinity 1 by 3n whole factorial. This is equal to 1 by 3 into e plus e to the power omega plus e to the power omega square. Okay. So evaluated the value of this summation. Now, can you think that this should be a real number, right? This should be a real number. The value should be a real number. Okay. Then why we are getting complex number? So let's simplify this more. Okay. Let us simplify this more. So let's do it. So we will write this as 1 by 3 into e plus. Now see, I am going to next page. So omega, if omega is the cube root of unity, then you know that the value of omega is minus half plus root 3 by 2i. Then omega square will be equal to minus half minus root 3 by 2i. That is simple cube root of unity. Okay. So you need to remember the values directly. Actually, this is very helpful. Okay, not for only this question, it is very helpful. So yeah, let us put the values. So we will get e to the power minus 1 by 2. Now here we will see that we are getting minus half plus root 3 by 2i. So we can write this e to the power omega c e to the power minus 1 by 2 into e to the power root 3 by 2i. Because we know that if base is same, then in multiplication power adds, right? So if we add this, so we will get this omega again. Okay, okay. Plus, now see here, same logic. Here it is e to the power minus 1 by 2 into e to the power minus root 3 by 2i. I hope the logic is clear because omega square is equal to this. minus half minus root 3 by 2 I. Okay, so yeah, done. Okay, now this is 1 by 3 into e plus, now this e to the power minus half is common for the all, right? So e to the power minus half is equal to 1 by root e, right? This is actually 1 by root e. So we can take 1 by root e common. So here we will get e to the power root 3 by 2 I plus e to the power minus root 3 by 2 I. Okay. Okay. No problem. Now see. We got e to the power root 3 by 2i. Now this is Euler form. This is Euler form. This is the Euler form of that complex number whose modulus is equal to 1. Right? So we should convert this to polar form. How we will do it? It's very simple. So here what is the argument, can you say? What is the argument? Yeah, the argument is root 3 by 2. Root 3 by 2. Can root 3 by 2 an angle? Yeah, it can be. Okay, it can be an angle in radians. Okay, all real numbers are radians. You know that. So, yeah, there should be no problem. So, you can write this as cos root 3 by 2 plus I sine root 3 by 2. Right? And same logic, it will be minus root 3 by 2i. This is equal to cos of minus root 3 by 2 is equal to cos of root 3 by 2, right? Plus, because cos of minus theta is equal to cos theta, you know. Plus, now here we will get I sine minus root 3 by 2 because this is the argument for this. Okay, this is the argument. Now we can move this minus sign outside of this sine function, right? So we will get minus sign here, right? We will get minus sign here, simple, and we will get this. Now if I add these two, so we will get e to the power root 3 by 2i plus e to the power minus root 3 by 2i. Here we will get these two terms will be cancelled out and we will get 2 cos root 3 by 2. Now this is the real function. This is a, right? This is a real value. Okay. So yeah. Now simple put that value, we evaluate it. So we will get 1 by 3 into e plus, we got 2 cos root 3 by 2. So we will write it as 2 by root e cos of root 3 by 2. And that is the answer. That is the final answer. You can say, see that this is a real value, right? This is a real value. Okay. So that is the complete question. Okay, I evaluated the answer. This is the answer. A very, very good question. Out of the box thinking. Okay. So yeah, I hope you enjoyed the video. Make sure to like, comment and share and subscribe to our channel for more amazing videos and concepts. Thank you for watching the video. Happy learning.